Welcome back. We're going to continue our discussion on AP Review. For this example here, we are going to take a look at the 2016 vector equation. This is a really good question. There's a lot of little intricacies to it. And I would think most students on this one taking BC Calculus should be able to score at least 6, 7 out of 9 points on this one. It's not that bad to do. So let's take a look. So we're given at time t, the position of the particle is moving along the xy plane. And we're given the following parametric equations, x of t, y of t. So remember, we're defining our position in terms of time. So that's really what this is, position in terms of time. That is a parametric. And they give us dx dt. So remember what dx dt is. This is the horizontal velocity. In other words, how fast the particle is moving horizontally. And then they say the graph of y consists of 3 line segments as shown above. And they tell us this. At t equals 0, the particle is at position 5, 1. So they've given us some sort of initial condition. So chances are I'm probably going to have to do the FTC and solve for something here. So if we take a look right here, they gave us the graph of y. So not the derivative of y, but the position of y at any given time. So at t equals 0, the y value is 1. At t equals 2, the y value is negative 1. And the slope of the line I know is going to give me y prime of t. So I'm going to write that down. Y prime of t is the slope. So remember, this is telling us the vertical velocity. All right. Sorry, my penmanship is terrible right now. So let's take a look at part A. Part A says we want, there it is, find the position of the particle at t equals 3. So that's not that bad to do. We want to find the, We want to find the position at t equals 3. Now, y of 3 is going to be really easy. That is just the value of the function up here. Be careful. So if I look right here, it's going to be a little bit tricky because we have to use the slope. From 2 to 4, the slope goes up 1 over 2. So it has a slope of 1/2. So if I'm at -1, that's going to put me here at -1/2. So I got my y value of -1/2 right there. Next, we have to find x of 3. Well, to get x of 3, well, they only gave me the velocity of my x-coordinate, so I have to integrate my velocity. Now, I do know my initial position at t equals 0. My x value is 1, so I'm going to go ahead and use that. So I'm going to go from 0 to 3. X prime of t dt equals x of 3 minus x of 0. Now, you are going to get exactly 1 point for setting all of that up. Next thing we have to do, we're going to plug in our initial condition, which is 5. Now this I can type in my calculator. And if you did that, I don't have my calculator here since I'm using my iPad here. We're going to get 9.377. And that's going to equal x of 3 minus x naught. But what is x naught? That's my initial x position, 5. Now remember, to get my integral, I typed in this t squared plus sine 3t squared. And I'm going to put the 5 here because that's my initial x position. So x of 3 becomes 14.377. So let's talk about points. Just using the initial condition plus 1. And then the final answer, you're going to write your answer as a point. So the position is going to be the following. We found x to be 14.377. And the y we said was -1/2. And you get 1 point for writing it as a point. An easy 3 points. I know I don't have to calculate it, but we've been practicing that all year long, so that should be pretty good for us. Part B, let's take a look here. Now we want to find the slope. Well, we saw this in our example with our polars. And so anytime we want to find slope, slope is always the change in y over change in x. It's always dy dx. So for part B, if we want to find the slope, it's always dy dx. Now, in terms of parametrics, or like what we have here in terms of a parametric, it is y prime of t over x prime of t. And you're going to write that down. And we want to let t equals 3 here. So we're going to let t equals 3, y prime of 3 over x prime of 3. Now y prime of 3 is the slope at 3. So if I go here, the slope at 3, we already know that as just 1/2. So I can just write this as 0.5. Remember, they gave us the graph of y right here. We just had to find the slope of that line, and that's pretty easy. The slope of that line is 1/2. So therefore, y prime of 3 was 1/2. And that's what I put down here. Okay, so next we need to get x prime of 3. To do that, we plug that, we plug, come on, we plug that into our equation. Now I'm just going to use my calculator here. So y prime of 3, if we type that in our calculator, you would just, it would be like dx dt at t equals 3. And that is 9.956. And we're just going to leave it. Although if you're like, I got to simplify it, we would get roughly 0.05, something like that, right there. All right, so that's not worth much because it's just plug and chug into the calculator, +1. Now for part C is now looking for the speed of the particle. Now remember, to get speed, we always said, is the magnitude of the velocity. So x prime of t squared plus y prime of t squared. And to do this one, well, this one we're going to plug in. We want to find the speed at t equals 3. So we're going to find x prime of 3, square that, plus y prime of 3, square that. So from part B, actually, it doesn't take too much. From part B, we found x prime of 3. That was just this 9.956 squared. Y prime of 3 we said was 1/2, and we're going to square that. You don't need to type all this in. You just need this part right here, but it doesn't hurt. And if we type that in our calculator, we get 9.969. So how many points did we get here? Let's take a look. 1 point for your expression, just having that out, and then 1 point, of course, for your answer. Notice I'm not having to take the derivative by hand. I'm just typing it in my ever-trusty calculator. All right, part D. We're mathematicians. We love the part D. Now we're asked to find the total distance traveled by the particle from 0 to 2. Now this is a little bit trickier for us right here. And that's mainly because of the y. Remember, to find total distance in terms of a vector, to get the total distance, we have to, can't spell distance. It is the integral of the magnitude of our velocity vector from A to B. That's how, of course, we find total distance. But the problem is, if we were to set this up from, let's say we want to find the total distance from 0 to 2, if we were to set that up, we would have a problem with the y values. And that is because for the y slope, the slope changes at 1. So this won't work for us because the slope for y changes at 1. So we're going to say that the slope for y changes at t equals 1. So for that, we actually have to do two intervals, 0 to 1, x prime of t squared dt, plus y prime of t squared dt, plus 1 to 2, x the square root of x prime of t squared, plus y prime of t squared dt. We actually have to set it up two different integrals because we break at 1. It changes. The slope for y changes at 1, so that's going to hurt us. So if I want to rewrite it now, between 0 and 1, we would just plug in the derivative that they gave us for x prime of t squared. That is what they gave us right here. That's going to go in their integral there, squared. Plus, y prime is just the slope from 0 to 1, which is just -2. And that's what I'm going to put down here real quick. So plus -2 squared dt. This is the slope of y on the domain 0 to 1. Plus 1 to 2, the square root of x prime of t squared. same one here because x prime is just going to be the same because it's not changing. Plus, whoops, don't put the square on the inside. Don't put the square on the inside. Don't put the square on the inside. Put the square on the outside. Plus, now we need the slope of y on the domain 1 to 2 dt. And to get that, we go up here from 1 to 2, the slope is just 0. I can take a look there. So I can just plug again 0, and I would square that. Now, so let's take a look at how many points this is worth so far. You would get 1 for the integral expression, just be able to find the slope. Just be able to write it as an integral, plus 1 for having them both combined. And now we got to get the answer because they do want us to actually find the total. They don't want us just to estimate to write it. So if you type all in your calculator, you get something like 4.350, but they would also accept 4.349 as well. And that, of course, would be worth another point. All right, so I hope you do enjoy this video. We're going to take a look at a polar function next. Please come back and we'll take a look at that. See you soon.